Hi everybody, now in the second video we're going to talk about how to do the application, the map coloring application we talked about in the previous section, right, in the video. And we're going to just do that in matlab, right? And here, if you recall, that is the image that we just draw on the tablet, right? And before doing that, I just plot or sketch the image on a piece of paper with a pencil, and I also name the region numbers, right? And when I convert it into a digital format, I just pre-process that using MS Paint, or you can use something like that to delete the some artifacts. And these numbers were artifacts, right, to me. And there were some little annoying, like just little artifacts. For example, this is like not much, but let's there was something like little, like 1 centimeters or something, just annoying boundary line. And okay, this is what I did, right? And I called it pick1.png. okay, all right. Now we're going to use matlab, right? Okay, one by one we're going to focus on that. Right, let's do that. This is going to be the first code. And yeah, right, image rate. We're just going to, and let me show you. Yeah, pick1.png, we have that. We are in the same file, right? We have that object in our folder, so everything is cool, right? All right, we just import it, and let's check the what it is. It is uint. All right, then let's check the size. It will be a tensor. When I say tensor, I mean like a matrix, but 3-dimensional. And why 3-dimensional? Because we talk about this RGB, right? Channels, all right? And okay, so RGB to gray. You can do this type of operation in matlab, by the way. There won't be any problem. And I'm looking at this RGB. Yeah, now let's check the plus and size, right? Let's check what it is. uint. Okay, that's cool. And let's check what it is. And this is matrix. All right. Yeah, imshow. You can use imshow. This is another very important function. What did I do wrong? Wait a sec. What? Let me just do that. This is 1. This is 2. This is 3. This, yeah, okay. All right. This is the image and figure. This is matlab's object, okay. And let's check the size here. 600 and 800 something, right? And check the minimum value. Okay, 67. Maximum value 255. Okay, and we talk about that before that, right? And let me do something like this to check the imhis is a histogram comments for specifically used for this is being used for image objects, right? Here we can see this image even is some, you could use some thresholding. Here we can see that. All right, okay, now yeah, threshold section here. Let's check that again, by the way. Yeah, let's use 140. Okay, initially use that. I called it logical because the output of that will be a matrix where each entry is true or false, so it will be a binary, basically binary object. Okay, and I cast it into a double object, right, using double function. This is a casting operation, right? Iteratively adjust the thresholding level, right? And yeah, you can use this very good this is good. Montage is a very good function where you iteratively, especially when you do iteratively do something. For example, we are doing thresholding, and thresholding usually some iterative process, right? And you can just tune this 140 value, right? And see if you can get better thresholding, success. And let me just indicate, for example, what we want is this. We want to be having some image, right? And all the boundaries are clearly expressed, and there is no connection between the regions. For example, this is region 1 and this is region 2, for example. And for example, that it looks like there is a bit of whiteness, and there is might be some connection, but we check this, and yeah, there is not a connection. Restore view, right? You don't want to have a, for example, this 0 section here, right? Otherwise it would consider region 3 and region 5, for example, as one region, right? And you don't want that. And it looks okay, I guess, right? Of course, you can just use some opening and closing, or erosion type of operations as well, but we're not going to be focusing on that. I mean, I just did that example, but this is not an image processing course, so I'm not going to talk about that. And there is a very good image processing course where Rich Radke, I guess the name of the professor, teaches that course, and I am going to share that link, his lectures on YouTube, right? The link will be in the description. I hope I don't forget that. And I'm looking at this. Yeah. For example, you can basically do some opening and closing operations to get rid of that type of little artifacts or annoyances. This is a real terminology. Of course, I'm joking. Anyway, and plot a dot on the image. I don't know why I did that. I don't know why I did that. Yeah. Yeah. If you can, for example, normally you can just use grid on and grid minor commands, but for some reason at the time where I code this script, it makes sense. It made sense to me to put bunch of, now you're going to see bunch of red dots randomly generated and placed randomly on that image to determine some interior points in every region. Now you're going to know what I talk about. Okay, randy is random integer. Okay, and this is the syntax, just row number and column number, and no, I made a mistake. Minimum number and maximum number, the range. So for example, you want to have a random number generated, an integer random number generated in the range from 80 to 120, right? 120. And yeah, you would write 100. So 80, that was I did say 80, I guess. 80 and 120 you will write here, and you only want, let's say you want 10 numbers, right? 10 row and 1 column, right? Okay, you can just use that, and I just call it x1 x2, and just this is x location and y location, and just like the location bunch of random numbers to place on the image. Here, this is the image, this is our image. Here I just set hold on to to basically to have by the way, you can, if you wanna do, I mean, it is not important at this stage, but if you have some, if you wanna, I mean, we are using random things, right? And however, if you wanna, and if you don't use that, let's say I open that and I use that, right? And you sent the code to your friend, and he sent or she sent, she used that code, and she would get other random numbers, right? And if the location of that generated random numbers you want to, you know, you want them to be same, the locations that you generated and locations that your friend generated, you would use RNG, and this is like seed number. I just written 1 2 3, but you can just write you know, 1, for example, right? Let's say for some reason I just got the habit of writing 1 2 3 anyway. And yeah, this is like a long detour. And for example, we have 8 1 2 3 4 5 6 7 8. Yeah, there are 8 regions, and from now on we want to have 8 locations. For every regions we want to have a interior point, and we're going to define or manually code the location of that interior point, right? Okay, for example, we can use 150 and 160, right, as a location of the interior point corresponding to region 1, right? Okay, I'm going to close that. And basically this is what I did. This I didn't show you this, and because you wouldn't want to, you know, see that boring process. And there are 8 regions, and this is like X location and this is Y location, right? And I guess I just messed it up here, and so I just changed the, you know, and I just changed the 700 comma 400 to 400 to 700. Okay, and but it doesn't matter. It's not a big deal, right? You will probably check every step, you know, one line at a time. And okay, you just want to, for example, let's say, let me just explain a little more. Oh, I made a mistake. Anyway, I panicked a little unnecessary because matlab is complaining about something. RGN, right? Random generator, I guess that stands for. Right, let me get that. And for example, this is region 1, right? And 150 for example, right? Yeah, we can just use that. For region 2, right, here we can use 300 and 200, and we use that. This is the process what I was trying to, you know, explain. Okay, after that we just stacked, you know, each location on top of another, right? And I constructed something called region vector, right? This is composed of, you know, an interior point locations basically. And while doing that, I just, you know, do something like this. Let me, what's going on? Yeah, I just did something like this. For example, this is for region 1, right? And let me just show you again. Gray connected, yeah, this is like the important part. Gray connected is a function where we just supply image, and this is gray image, okay? And it can be a binary image as well, right? 0 1s or 0 to 55s, right? And you give X location and Y location, or Y location or X location, or the, you can check that, right? And X location and Y location of an interior point, right? For example, region 1 interior point is 150 and 150, right? Okay, and after that, and using montage is like just plot 2 image, you know, next to each other. Okay, this is for region 1. When I was, you know, assigning these values, I just wanted to, you know, check them simultaneously as well, right? And this is for region 2, right? Let me just make it smaller. Okay, here region 2, right? It makes region 2 values 1 and other ones 0 basically, right? Why that is important, we're going to use in a second, in a moment, I guess, and you're going to see why. And okay, that was some use case, I guess. And here, just I didn't like it actually. Okay, yeah, now that's okay. So tile layout is like if you wanna plot two, graphs next to each other, and you can use that. I assume you probably would like to use subplot, like something like this. Let me explain. For example, something like this subplot, and two rows, one column, and the first one is, and you will write plot dot dot dot, right? You would something like that. However, if you are really engaging some, I guess mixed visual images, for example, one plot may be a really simple sine function graph, and the second image would be a really image, like image of a pencil or something, right? And the third image would be a three-dimensional function, right? And for fourth image would be histogram or something, right? They're all mixed. They don't have much to do with each other. So in that case, I guess you would like to use tiled layout function, or you wouldn't like to use subplot, I guess, right? And there are one row and two columns, right? And to plot after writing that, to say, hey, I'm going to plot or display some image, you just say next tile. As soon as you write that tiled layout function, you say next tile, and then you just use that. Here I just draw or plot the and display the image, our image, right? Thresholded image, and I just wanted to display the number of that region here using that text command, right? Text command. And here, since we have the interior point location of interior point for each region, we just use that. And for the next image, you write what is that? That's okay, got it. You know what, let me just do that for one. Okay, here, this is it. This is what I'm talking about. Gray connect. This is the important function. And here, since you are able to see that, and since we have called regt, right? I guess region temporary or something. Here, this is the output, right? This is the output. This is the region 1. This is this is the thresholded image. And by the way, you can, by using color map or mapping the colors, you can just, for example, you can do better than yellow and blue. You can do like white, black or something, right? All right, this is the R and blue, right? Let me draw that one more time. Here, R, red and blue, the number, region number, right? Okay, and now we're going to automate this. Yeah, area layout tensor, we just talk about that. Here, size, the same size. I mean, you will basically have 8 images, each one having the same size of that our original image, right? Grayscaled image, and 8 image stack on top of each other, right? and we just call that area layout tensor or something. I guess in the video I called region. Anyway, it doesn't matter. The name of that, it doesn't matter. This is just a name, right? Variable name. And since there are 8 regions in the example, right? Array connected. This is the image, thresholded image, and this is some interior point location. All right, and this will give us some binary, right? Black and white binary image, right? And you can typecast it by using double function, okay? And then you just, populate that section of that area layout tensor using that binary image or matrix, okay? And let me just run that. All right, and after running that, and now we will see if there's anything wrong with that. Okay, let me just delete some unnecessary stuff. Is there some problem? I guess no. Okay, yeah, oh, I make a mistake. Okay, wait, so wait a sec. Can I just do that here? Can I do that? Yeah, okay, now you see 3 4. I guess I shouldn't maximize that. That kind of that was kind of distracting thing. Okay, let me do. Wow, I don't know how should I do that. Okay, just I'm going to run that section and then I'm going to click on that, part. All right, 1 2 3 4 5 6 7 and explosion. Okay, all right. This is the general idea, and actually we just completed our task, and from now on I'm going to be engaging some entertaining stuff, right? And plot the covered map. It says, wow, this looks complicated. I guess I didn't update that. Anyway, one line at a time. Okay, one line at a time. We're going to analyze that. And first, here, this is our thresholded image. We are used to seeing that. Here, let me just do that. Okay, construct the outline image boundaries. Okay, we're just creating some image. When I say image here, I literally say a matrix, and I use once, right? And then I multiply it with 255, right? Once function, matrix, or the image, or again the matrix, where each entry is 255, and again 255 and 255 for. This is what I called, or what I've taken that from the matlab's website. There was some example regarding to that application. I just called red channel, green channel, and blue channel, and record RGB, the acronym. And okay, and now we're going to update our G and B, channels. Okay, here im2 logical. What was that? I can't even remember. Before, I guess when we first thresholded, yeah, this is it. Here we just imported we use RGB to gray, and after that we thresholded here. We just thresholded, and as soon as you threshold it, it is like, let's not focus on it. Let's consider we haven't done that. Okay, just disregard, okay, this highlighted region section. Okay, and we just threshold it, and as soon as you do that, MATLAB will give you a logical, binary matrix. Okay, logical equals binary here in that context. Okay, and that's why I have to use double function to cast that into a double matrix. And im2 logical is binary matrix, basically zeros and ones. Okay, all right, now we're going to move from here. Wait a sec, where is that? Okay, now we are here. Okay, we just plot that and we generated just three matrices, each one having 255 as their entries, right? And the same size with our original image. And I use uint8, right? Okay, it is necessary for the construction of RGB, not for RGB per se, but for we're going to be creating some little image. Okay, this will be exported from matlab to outside, right, in our computer as a PNG file or something, and that's why we need to do that. Okay, all right, I'm guessing you can use other int types, but I just got that from matlab's website. This is like the easiest things and simplest solution I'm considering here. Okay, what was that? And here, if you're not sure what it is, just plot it. Okay, just don't get alarmed by that. Im show here, I'm going to probably cast that into, or maybe I don't actually. Okay, let me do that. Yeah, here, this is outline, right? We just threshold it, right? And we got this. Okay, and we expected that. Okay, and when you see white, it means there are ones here, and when you see black, there are zeros here. Okay, because in RGB context, 0 0 0 means black image, but 1 1 1 wait a sec, 1 1 1, right? R equals 1, B equals no, R equals R equals 1, G equals 1, and B equals 1 equals white color. Okay, and okay, I guess that was not a problem here. And after that, since this is binary, I noted that, by the way, I noted that, and let's do that here. This is the im2 logical, right? This is what you get when you threshold it, and this is get that again. Let us remind ourselves what it is. Okay, and since this is binary, you just typecast it into uint8. Otherwise, it would complain if you make that double, right, and try to cast it into a double object or number. It would complain, I guess. And all right, what is trying to say here? You are going to see that. And RGB, I'm just saying R, and here construct outline image boundaries. Okay, outline image or out boundaries of that boundaries section of that image. Okay, and I don't know what it is. Cats concatenate, I guess, right? And it basically gives you some image. And when I say image, I mean image, right? RGB, like 3 channels, like little image. You can just export it. I mean, you can export grayscale too, but this will be the kind of image that you're used to. Okay, and all right, so let me plot that. Okay, so outline here, outlines are colored with red color. Okay, so I say region, make region 1 red. Okay, here again you can just do that, Just let's focus on here. We are at this line, just don't be alarmed. Okay, easy, right? And step by step we're going to analyze this. And I guess I was focusing on some other regions, that's why I called it, I just number that here, assign some variables. And here the same, this third line and this third line same, so I don't know why I did that. Anyway, you just do some things that you don't know why you did that in programming. That's general, I guess. Here again red, right? Yeah, I was doing step by step fashion. Now I got it. You set into logical, right? But here you use your tensor, not the whole components of that tensor, but only the first image in that tensor, or first grayscale. Actually, I shouldn't say grayscale, for first binary image in that tensor. Okay, and that binary image, the ones indicate the region 1 and the zeros indicate the other areas. Okay, all right. This is, you just give some binary image and it can create, and you just give some binary image, right? And also you determine some which color you want to make that region, right? And that's it. I guess there's nothing you have to do, right? So wait a sec. Okay, yeah, this is the function name, so let me use that. I'm going to do one more thing. Okay, all right, everything going fine, just relax, just breathe in, breathe out. And here we're going to plot that here. Basically this is what we called region 1, right? And this is it. Okay, and I basically manage to cover some given region in that image. Okay, and since I did for only one region, this looks like that. However, we can also add on top of region 2, and that will be blue color, for example. That will be good. Region 3 will be other colors as well. And now we are going to do that. And that's why, since this looks really ugly, very messy, right? We are going to create some function. Let me get that. What I did basically, I just copy this seven lines. I just copied that, right? I just copied that and paste it here, right? And you just give me some tensor again. 8 regions we have, right? So 8 binary images stack on top of each other, and that's why we have 3-dimensional matrix. Okay, and region number, for example, which region you are interested in. Let's say region number 2, for example, right? You want to make it blue, for example, and that's why we didn't say blue. That will be, too restrictive. Why restrictive? Because you would use, in that case, in the future, and we're going to be looking at that kind of applications as well, you would use, well, 1, 0.2, 0.3, for example. You wouldn't always use, right, 0, 0, 1 or something, right? Only zeros and ones, right? You wouldn't use only blue, red or something. You would use some shades of blue and gray, and shades of gray, for example. It depends on how you prefer your images to look like. And okay, that's why use that. You are going to give and something like this, for example. I'm talking about, maybe when I explain stuff, I have the tendency to make them look or sound complicated than already needs to be, right? Yeah, this is it. For example, and let me just here write that, and this is R, this is G, and this is B, and each one takes values 0, 1, right? In that interval, each one is in the interval of, okay, 0, 1. All right. For example, you would here write that, for example, and that's it. I mean, this is like 6 lines, and after that it would give you like 3 channel, right? RGB channel. This is like would give you a tensor, right? An image. You can just visualize using image sc and image imshow, right? Imshow function, and you can export that after that, and you can also add, and we are going to be covering that now. So this is it, right? Just that we use that function from now on. Okay. All right. This is the syntax. Okay. And here I want to, I give the tensor where in that there are 8 regions and 8 binary images in the tensor. Okay, that's all right. We covered this. And for region numbers, for the first region, we want to make it R, right? We want to make it red, for example. And I can, use image sc function to visualize the, returned image or returned output of that function we, written. And we can use text function to, indicate the region number on top of that region. I'm going to show what I mean here. This is what I mean here. One, there is, let me make it pronounced. Okay, there's 1, right? And okay, again, I guess, trying to make region 2 blue or something like that. And yeah, region 2 here, we can just do that here, region 2, and it is not a good color, I guess, blue and black. It makes my eyes hurt for some reason. Here, second region and blue, RGB blue. Third component is 1, all right, so pure blue, right? And again, text function. After that, I'm looking at this outline. We know what our outline is, only the boundaries, right? And I guess I wanted to plot that as well. Yeah, we just plotted the outline and also indicated our region 2. All right, and region 2 was blue. We just determined in the couple lines back in. All right, and yeah, we also have like this here, region 1 red, region 2 blue, and other are black, and the outline is red. Okay, and also maybe use something like that here, 1, 2. All right, there are 8 regions we can do. And I did it actually. And you can use for that type of, if you're not sure, you can use, let me here write that, you can use something like that if you wanna create 3 digits or some binary numbers ranging from 0 to 7, right? This is like the thing that you will do. Okay, and I'm looking at this here. Let me, is there a problem? Wait a sec. No. All right, I just used the same concept. Of course, you would use for loop for something like that, but I wanted to make it, pronounced, right, highlighted and clear as possible. So region 1, region 2, 3, 4, 5, 6, 7, 8. Okay, and here region numbers and the color. For example, R. This is R. This is blue. R. No, this is green. RG. and R plus G, I don't know what it is, to be honest with you. RGB, and this is blue, and this is R plus RGB, R plus blue, red plus blue equals, I don't know exactly. And now we're going to learn what it is, by the way. That's why it is helpful, beneficial for you to watch that videos. And RGB and green plus blue equals what? We're going to find out exactly. And this is, I know what it is. This is white. Okay, 1 1 1 equals white. Okay, and 0 0 0 equals black, but we are going to use black for to indicate the layout. Okay, boundaries. And I just ran out of integer numbers, so I just typed some partial numbers. Okay, here at the end we just sum all of them together, and I called it im total and outline image. And now we are going to do that, and we have a really beautiful image. Okay, look at this. By the way, let's study some colors. All right, region 1 is R G. Okay, R red. All right, region 2 G green. Okay, region 3 red plus green equals, I didn't know that, yellow. Okay, and RGB, this is 4 blue. Okay, and 5 red plus blue equals pink, I guess. Okay, and green plus blue equals, yeah, some greenish blue or bluish green. It looks like the, I don't know, like I want to say cyan, but I'm not sure. The Twitter color. Okay, and 7 is 1 1 1, and this is white, and this is like 0.5 0.51, and this is, it looks like clear purple. Purple. I don't think. Anyway, it's violet color. I don't know. Anyway, okay, this is the and result, and we can export it and using write. Yeah, let me write that. You can use something like that, and here you can use that. This will be your image, and this will be your my image dot png, and you can just export that. What did I do? Anyway, you can just export that, right? And I should do that actually, but before that I wanted to use that in right, if I or add in right to see if the syntax is correct. Okay, so matlab, you are giving me a bunch of information. Wait a sec. Wow, there are lots of things here. Come on, right. A file name and format. Okay, isn't there any some examples? I guess that's good. Wait a minute. Before doing that, I want you to look at this. Section, okay? Or my image, not a good name. Pick one colored would be better name, I guess, right? All right. Please look at here. Okay. Yeah. Pick one colored, and let me show in Explorer. Okay, and let me, yeah, we just export that image. All right, this is it, folks. Now we're going to focus on some country map coloring application. Okay, all right, thanks for watching.